All right, lesson 1.8 is on estimating quantities. So we're going to start using powers of 10. And today, which is going to lead us into scientific notation, we're going to just really focus on estimating, just doing some rounding so we can get the size of some things by powers of 10. So let's talk about the powers of 10. So we can use powers of 10 to estimate and compare really large and really small numbers. It says fill in the table to represent the actual values of large and small powers of 10. So we start with 10 to the 0. Remember, anything to the 0 power is 1. Anything. So if we go 10 to the first, that's just 10. 10 to the second, remember, means 10 times 10, which is 100. And 10 to the third is 10 times 10 times 10, which is 1,000. And so then 10 to the fourth, if we start to see a pattern here, would become 10,000. 10 to the fifth is 100,000. If we were to multiply 5 tens together, 10 to the sixth becomes 1,000,000. And then 10 to the seventh would be 10 million. And we could keep going, but we're going to stop there. So again, remember, this just means 4 tens times by itself. Now you can start to look here, and this only works for tens, but you can see 10 to the second, it's a 1 followed by 2 zeros. 10 to the third, a 1 followed by 3 zeros. And that pattern holds true for tens, but only for tens. Okay, so then look at this other one here. Again, 10 to the 0 power. Anything to the 0 power is 1. Now, what is 10 to the negative 1? Well, remember, we just got done doing exponents, where it says if we have a negative exponent, we take the reciprocal. And so that becomes 1/10, or 1/10 written like that as a decimal. Same thing here. 10 to the negative 2 would be 1 over 10 to the second, which is 1/100th. And then you can start to see a pattern. 10 to the negative third becomes 1,000th. 10 to the negative fourth is 1/10,000th. Now, we can't really, I know there's a 0 up front, but we know how I said the hint here, we have a 1 followed by 4 zeros, like in this 10,000, 10 to the fourth. Think of this more as 4 decimal places. I know we have the 0 here, but it's 1, 2, 3, 4 decimal places. 10 to the negative fifth is going to be 100,000th. Okay, so again, 3, 4, 5 decimal places, and that 1 occurs there. And then 10 to the negative 6 is 1,000,000th. Trying not to, sorry, that got a little sloppy. Miss a 0 here. And then 1 to the 10 millionth. Not 1 to the 10 millionth, just 1/10 millionth. 1, 2, 3, 4, 5, 6, 7. Okay, so you can see how 10 to the negative 7 and 10 to the 7th, as the smaller or bigger they get, the actually easier it is to write as a power of 10 compared to all those zeros, counting them, making sure you didn't miss them like I did. So to use that, we're going to say estimating with powers of 10. So to estimate a number using a power of 10, round the value. We're going to round it to its leading digit. Then rewrite the value as a single digit times a power of 10. So we're going to round it and then rewrite it times a power of 10. For example, we can estimate 9,450. Well, remember, we're going to round the value. We're going to round it to its leading digit, that 9 there. So that 4 behind it tells me that it's going to say 9,000. Okay, so we're going to round that to 9,000. Or 9 times 1,000. Round the value, then write the value as a single digit times a power of 10. 1,000 is a power of 10. Oops, right there. Nope, right there. Which means we could also write it, if we look right here, 1,000 is 10 to the third. We could rewrite this as 9 times 10 to the third. Same thing here. Additionally, we can estimate this 0.000879. Its leading digit is the 8 there. So I'm going to look the digit behind it. That 7 tells me to make this 0.0009, because we're going to round up. Or, that's tenths, hundredths, thousandths, 10 thousandths, 9 times 0.0001. And if we look up here, 0.0001 is 10 to the negative fourth. So 9 times 10 to the negative fourth. Okay, this is going to be leading into scientific notation, but right now all we're doing is practicing. So it says estimate the following values by rewriting each as a single digit times the power of 10. So let's do the same thing with these. So we look at the leading digit, the 7 here. The 2 behind it tells me it's going to stay 7. So I'm just going to think of this as 700,000, or 7 times 100,000. Now 100,000, you can either look up here at the chart or count the number of zeros. 100,000 is 10 to the fifth. So I'm going to rewrite this as 7 times 10 to the fifth. Again, we're just estimating and rewriting with powers of 10. It's going to lead us to scientific notation. Okay, right here, look at the leading digit 1. The 9 behind it tells me that that 1 is going to become a 2, and this is going to be 2 million. Or 2 times a million. And this, a million here, is 10 to the 6th. So it's 2 times 10 to the 6th. All right. This 12 million here, and that 1, look at the 2 behind it. That 2 tells me I keep it as a 10. And so that's 10 million. Actually, I'm sorry. It's a 1, well, it is 10 million, or it's a 1 times 10 million. And there's 1, 2, 3, 4, 5, 6, 7. So if we use that hint with 7s, we can rewrite this as 1 times 10 to the 7th. All right, couple more. Let's just do a few more examples here for this set of notes. Estimate the following values. We're going to do the same thing. But this time they're really, really small numbers. So I'm going to look at that 2 here. And the 4 behind it tells me to leave this as 0.002. All right, so that becomes tenths, hundredths, thousandths. This is 2 times tenths, hundredths, thousandths. 1,000th. So if you look at the chart up here, 0.001 is 10 to the negative third. So I can rewrite this as 2 times 10 to the negative third, because negative third is going to be 1,000th. Same thing here. Look at this 5. The 6 behind it tells me to make that a 6. So that's let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6 is in the 6th position. So this is 6 times 0.12345 6, because we want that 1 times that to stay in that position. So you have 5 zeros or 6 decimal places. That's right here. 1, 2, 3, 4, 5, 6. 10 to the negative 6th. So this is 6 times 10 to the negative 6. And then to finish up the set of notes, look at this 8 here. The 7 behind it tells me to make it a 9. So it is 1, 2, 3, 4. 1, 2, 3, 4. Tenths, hundredths, thousandths, 10 thousandths, 900 thousandths. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. And if there's that 1, 2, 3, 4, 5 decimal places, that's going to be times 10 to the negative fifth. So this is the start of scientific notation. And right now, all we're focusing on is estimating to try to figure out the closest power of 10 that these things go to.